All right, today we're going to talk about how to add, subtract, or multiply by a scalar different vectors graphically. Okay, so let's start with addition. So this is standard stuff. We talk about it. So if I have two vectors, A and B, and I want to add them, we're basically adding the coordinates of the vector. So how does it look graphically? Let's start with coordinate system. We draw vector A. Vector A is going to start at the origin, in this case the end of vector A. The coordinates of the end of vector A is coordinates of the vector itself, xa, ya. And also we're going to draw in the same manner vector A plus B. Okay. And now let's look at the vector that connects end of the vector A and end of the vector A plus B. By definition, the coordinates of a vector are coordinates of the end of the vector minus coordinates of the beginning of the vector. So for this particular vector, coordinates of the end, x coordinate of the end is xa plus xb, coordinates of the beginning of this vector xa. So if we take xa plus xb minus xa, we get xb. Same goes for coordinate y. We're going to do ya plus yb minus ya, and we're going to get yb. So coordinates of this green vector are xb, yb, which means this vector is b. All right? So that kind of gives us an idea how to add two vectors graphically. So you take one vector, then you put the second vector at the end of you start the second vector at the end of the first vector, and the sum of two vectors is the vector that connects the beginning of the first vector with the end of the last vector. All right? Now let's look at a different way of adding two vectors, which is sometimes also useful. So if we take this vector b and change its location, we're just going to move it to the origin of coordinate system, like this, right? And now we connect the end of vector b and end of the vector a plus b. Okay? So now let's get rid of middle vector for a second. What we see here is a parallelogram, right? So basically these vectors a and b, when they're starting at the same point, created a parallelogram. And in this case, a sum of these two vectors is a diagonal of this parallelogram. That's actually, that vector starts at the same point as both vectors a and b and goes along that diagonal. All right. So again, there are two standard ways to add two vectors. We can take one vector, put another vector at the end of the first vector, and then the vector that connects the ends and goes from the beginning of the first vector to the end of the last vector is the sum of those vectors. Right? The other way is to put both vectors a and b, make them start at the same point. In this case, we're going to create a parallelogram, and then diagonal of this parallelogram that's coming out from the same, basically the diagonal that starts at the same point where both of those vectors a and b start is gives us the vector. Okay. All right. Now let's look at the case when we need to add several vectors, not just two, 3, 4, 5, and so on. So we look at the three vector addition and then generalize. So I have vector A. Let's say I want to add vector B to it. So we connect them at the end. Now vector A plus B is the vector that connects the beginning of the first vector and the end of the second vector, a plus b. And now if I want to add vector c, I'm going to hook it up at the end of vector a plus b, right? In this case, this vector is going to be a plus b plus c, okay? So now let's get rid of the middle vector. And what do we see? We see that really the rule of adding three vectors is similar to the rules, one of the rules, how we had two vectors. We just take those three vectors, put one after another one, and the sum of those vectors is going to be the vector that connects the beginning of the first vector with the end of the last vector. And that works for 3, 4, 5, 10, 100 vectors. All right. Let's look at the subtraction of two vectors. What you see on the right is basically definition, how we define subtraction. We subtract coordinates of the vectors. What we're going to do here is we're going to look at this red vector, okay? The vector that connects. So what we did, we took vector A and vector B, started them at the same point, and now we're looking at the vector that goes from the end of vector B to the end of vector A. If you look at the coordinates of this vector, again, we take coordinates of the end point minus coordinates of the beginning point. We find that coordinates are exactly coordinates of the vector A minus B, okay? So, and that gives us the rule how to subtract vectors. You start putting vectors at the same point. These have to come out from the same point. And the difference between two vectors is the vector that connects the end of those two vectors. And it goes from the end of the second vector to the end of the first. Okay? That's the rule. And the next thing, the last thing in this video, we're going to look at the case when we multiply vector by a scalar. But before we do this, let's just get some idea what's happening. So let's say I have a vector d. I want to find what vector 2d is, 2 times d. By definition, when we multiply a vector by a scalar, we're really multiplying both coordinates by that scalar, right? But on the other hand, you can actually verify that vector 2d is simply vector d plus vector d, okay? Same way as you do numbers, okay? Now, if you see what happened graphically, when you have two vectors, d plus d, you basically stack by the rules of graphical rules of addition of two vectors. We can just stack those two vectors one after another one, okay? And the resultant vector is going to be 2d. Okay? So what we see that vector 2d is really going in the same direction as vector d. Only thing, it's double in size. In a similar way, you can think if I want a vector 3d, well, I just stack three vectors d, one after another one. They're all going to point in the same direction, but, you know, the length of the vector 3d is going to be 3 times vector length of vector d, okay? Now let's consider the more general case. We have a vector d. We want to multiply it by some constants c, okay? Now in this example, we consider c positive in a drawing. So now if we draw a straight line through a vector d, what we find that really that coordinate cxd, cyd is going to lay on that straight line, straight yellow line, okay? And in this case, vector cd is just going to be the vector connecting, in this case, origin of coordinate system to point cxd, cyd, right? So the vector cd in general is going to be going in the same direction as vector d. The only thing is it's going to have a different length, right? And let's calculate the length of the vector. Okay, we're going to start with the definition of the length of a vector. So length of a vector by Pythagorean theorem is going to be square root of squares of coordinates of the vector. So in this case, it's cxd and cyd, right? Then we do some math magic, and at the end we're going to get square root of c squared times square root of xd squared plus yd squared. Now if you look at that, you'll see that square root of c squared is absolute value of c, and square root of xd squared plus yd squared is actually length of the vector d. Now here I'm going to point that square root of c squared in general, square root of square of any number, not that number. It's not going to be c, it's going to be absolute value of c. The only time when it's c is when c is positive or 0. When c is negative, we have to put this absolute value there. And in general, I recommend always do this, so you never forget that. Now, in our case, what we saw here is really c was positive, okay? In this case, we got what we got. Now, let's consider a case when c is negative. So what's going to happen? Again, I have my vector d. Now, if I look at cxd, cyd, when c is negative, again, that point, cxd, cyd, is going to lay on this line, straight line that goes through vector d. The only thing is going to be on the other side, which means that vector cd is going to be parallel to vector d, but pointing in the opposite direction. All right? So let's think about it. If I have a vector minus d, which means minus 1 times d, that vector is going to have the same length as vector d, but it's going to be pointing in the opposite direction. If I have a vector minus 2d, well, it's going to be the same as vector 2d, so it's going to be twice as long as vector d, but only it's going to be flipped. It's going to be pointing in the opposite direction. All right? All right, that's it for today. In the next video, we're going to look at an example. See you then.